Welcome to Casting Academy. Today we are going to discuss about the synthesis of mechanisms. Design of mechanism involves both kinematic analysis and kinematic synthesis. In kinematic analysis, displacement, velocity, and acceleration of the various parts of the link are to be determined. Now you see the 4-bar mechanism. This is crank, coupler, and oscillating lever. So here is theta 2 is the input angle and theta 4 is the output angle, and ABCD are the link lengths. So we want to find out the displacement, velocity, and acceleration in case of kinematic analysis. In case of kinematic synthesis, we decide the total skeleton of the mechanism designed to meet the specific motions, that is called kinematic synthesis. Mechanisms designed to meet specific motions in kinematic synthesis. Synthesis also materials to be used, its shape and size and arrangement of various links to meet the specific requirements. So synthesis means materials to be used, its shape and size and arrangement of links. Example number 1, to determine the number of teeth on a gear train to meet the get the velocity ratio. So to determine the number of teeth on gear train. Next one is to design a cam to give a follower with the required displacement motion. So next one is to design a cam to give a follower to displacement motion. Steps in kinematic synthesis. Number 1, type of synthesis. Selection of type of mechanism. It's the process of selection of type of mechanism. For example, you are choosing one particular application, gear train or cam or belt, etc. for a given application. So type of synthesis means selection of type of mechanism. During this stage, space consideration of the mechanism, safety of the aspects, and economics and manufacturing processes. Last one is material selection. All these are considered in this stage, type of synthesis stage. Next one is number of synthesis. It refers to the determination of the number and order of links and joints required for a specific application. It refers to the determination of the number and order of links and joints required for the specific application. Third step is dimensional synthesis. To determine the dimensions of parts, which means length and angles of the various lengths of the parts, that is we are going to find out in the case of dimensional synthesis. Next one is classification of synthesis problems. Classification of synthesis problems consider the function generation and path generation and motion generation. In case of function generation, just we correlate the input link to output link. It is the main function. So function generation is the correlate the input and output motion of the links. And path generation, a point on the coupler link is constrained to describe a path with reference to a fixed frame in case of path generation. And last one is motion generation. A motion generation means various rigid bodies or in a mechanism are used to guide the mechanism. Next, we are going to discuss an interesting topic, Freudenstein's equation. By using this equation, the lengths of the links of a 4-bar mechanism can be calculated. By using the Freudenstein equation, we can calculate the link lengths. Also, this is the synthesis of 4-bar mechanism. This is the equation of Freudenstein is also known as synthesis of 4-bar mechanism. Now you see the 4 bar mechanism. The input links are A and output links are C, which means crank, rocker, and B is the coupler and D is the machine frame, you know. So theta is the input angle and pi is the output angle. And also the three different positions of the input corresponding to output links. As you see, theta 1, theta 2, theta 3 are the three different positions of the input link. The same as well as for the theta 1, pi 2, pi 3 for the output links. So this is the input link and D is the output link. So 4 bar mechanism and three positions of the input and output links. Let input link AB of angular displacements are theta 1, theta 2 and theta 3, as well as output link have three positions pi 1, pi 2, pi 3. So input link displacements are theta 1, theta 2, theta 3, three different position. Same for the output links pi 1, pi 2, pi 3. Here, A, B, C, D are the dimensions of the link lengths. A, B, C, D are the dimensions of the link lengths. Freudenstein equation this one is Freudenstein equation k1 cos pi minus k2 cos theta plus k3. K1 cos pi minus k2 cos theta plus k3 equal to cos of theta minus pi. This is known as Freudenstein's equation. This is known as Freudenstein equation. Here where k equal to d by a, where k equal to d by a and k2 equal to d by c and k3 equal to a square minus b square plus c square plus d square divided by 2ac. For three different positions of the mechanism, as you know, theta 1, theta 2 and pi 1, pi 2, pi 3, for three different positions of the mechanism, equation 1 may be written as like this: k1 into cos pi, k2 into cos theta 1 plus k3 equal to cos of theta 1 minus theta pi equal to cos of theta 1 minus pi 1. K1 into cos pi 2 cos minus k2 cos theta 2 plus k3 equal to cos of theta 2 minus pi 2. So k1 and cos theta cos pi 3 minus k2 cos theta 3 plus k3 equal to cos of theta 3 minus k3. The equations third, fourth and fifth are known as simultaneous equations. May be solved for k1, k2, k3 either by elimination method or by Grammar's rule of determinants. Grammar's rule of determinants. The equation third, 4 and 5 are solved by elimination method or Grammar's rule. Now you are like this in the determinant format. Write down the equation delta equal to cos of pi 1 cos theta 1 1 and cos pi 2 cos theta 2 1 cos pi 3 cos theta 3 1. So this is the three positions and delta 1 equal to cos of theta 1 minus pi 1 and cos theta 1 1 cos theta 2 minus pi 2 cos theta 2 1 cos theta 3 minus pi 3 cos theta 3 1, and also the delta 2 cos pi 1 cos pi 2 cos pi 3 cos theta 1 minus pi 1 cos of theta 2 minus pi 2 cos of theta 3 minus pi 3. That column is 1 1 1 1 1. So here the theta 3 is like this. So now values of k1, k2 and k3 are values of k1, k2 and k3 are k1 equal to delta 1 by delta and k2 equal to delta 2 by delta and k3 equal to delta 3 by delta. Values of k1, k2, k3 are known, then the link lengths a, b, c and d are determined. Value of a and d is assumed to be unity. In practically, value of a and d is assumed to be unity to get the proportionate value of the other links. Now we are going to discuss the problem on synthesis of mechanisms. Problem: design a 4 bar mechanism to coordinate the input and output angles as follows. The input angles are 15 degree, 30 degree and 45 degree. There should be three positions of the input angles. The corresponding output angles are 30 degree, 40 degree and 55 degree. Input and output angles. Now the solution. As you first of all you write down the given data first. The input angles theta 1, theta 2 and theta 3. 15, 30 and 45 degree. Corresponding output angle pi 1 30 degree, pi 2 40 degree and pi 3 55 degree. As you know, mention the notation theta 1 for input angle and pi 1 for output angle. We know that the Freudenstein equation for the first position of the input and output link like this: k1 cos pi minus k2 cos theta plus k3 equal to cos of theta minus phi. This is the Freudenstein equation for theta 1 15 degree and pi 1 30 degree Freudenstein equation. So just we put the corresponding values to this theta: k1 cos 30 degree minus k2 cos 15 degree plus k3 equal to cos of 15 minus 30 degree. So we sort out, we obtain the 0.866 k1, 0.966 k2 plus k3 equal to 0.966. This is the equation number 1. So now you see the three positions. So A, B is a crank and BC is a coupler and CD is a rocker. So here 30 degree, 45 degree, 30 degree and 15 degree. 15 degree, 30 degree, 45 degree are the input angles. Corresponding output angles 30, 40 and 55 degree. There should be three positions: C1, C2, C1, C1, C2 and also B1, B2. So the three corresponding position of input and with respect to output angles. Similarly, for the second position, when theta 2 equal to 30 degree and pi 2 equal to 40 degree, the Freudenstein equation k1 cos 40 degree minus k2 cos 30 degree plus k3 equal to cos of 30 minus 40 degree. So we can put corresponding values. We obtain 0.76 k1 minus 0.86 k2 plus k3 equal to 0.985. This is equation number 2. For third position, when theta equal to 30, theta 3 equal to 45 degree and pi 3 equal to 55 degree, we obtain k1 cos 55 degree minus k2 cos 45 degree plus k3 equal to cos of 45 minus 55 degree. So corresponding values is 0.574 k1 minus 0.707 k2 plus k3 equal to 0.985. Equation number 3. So these are all simultaneous equations. So solving three simultaneous equations 1 and 2 and 3. This is separate chapter. Here I only taken the values because of the problem is too consuming length. So I can only take values k1 equal to 0.905, k2 equal to 1.01 and k3 equal to 1.158. Assume the length of A, which means crank, the link length is 1 unit. Assume A link length is 1 unit. Therefore length of the other links as k1 equal to d by A, as you know the formula, or from this d equal to k1 into A 0.905 units. Like this, k2 equal to d by C. So C equal to d by k2 0.905 divided by 1.01. Here we obtain 0.896 units. So K3 as you know the formula for K3 equal to A square minus B square plus C square D square divided by 2AC. So here we rearrange the equation. B minus B square equal to K3 into 2AC minus of A square plus C square plus D square. So put corresponding values of B square, K3, all the values. We obtain the value of 2.075 minus 2.622 equal to minus 0.507. So we obtain the b value like this, b equal to 0.74 units. Therefore we conclude the result is the diamond designed mechanism with the AB equal to 1 unit, AB crank length A equal to 1 unit and BC equal to 0.74 unit, the length C equal to 0.896 unit and AD equal to the length D equal to 0.905 units.